Okay, now we continue the introduction to the big data and machine learning. And as you know, the quantity of data has been grown a lot. And from the data that we see, twice as much information was created in 2002 as in 1999. That's about 30% growth rate. And UC Berkeley estimated that 5 exabyte of new data was created in year 2002 and 988 exabyte in 2010. But very little data will ever be looked at by a human. So now the knowledge discovery is needed to make sense and use of data. That's the reason. And we are at the beginning of this trend. And this diagram shows how the growth of the data has been changed. And the economists analyzed that digital information has been grown 10 times for 5 years, like what you see from the data, and which gives us a new Moore's laws in big data, in datas, and the smartphone forecast and others. And this slide comes from this. 이게 무슨 회사지? 이게 Huawei. Huawei. Yeah. Okay, and big data has 3 characters. Usually we say the big data has 3 characters, such as volumes and velocity and variety. And also, and this diagram comes from the Kent State University, shows how these factors affect the size of the size and the content and the meaning and natures of the big data. And this data from Kihasa and Korea National Institute for Human and Social Affairs, and that shows the classification of big data in volume and velocity and variety. And in the scale, the data volume has been increased 44 times from 2009 to 2020, and from 0.8 zettabyte to 35 zettabyte now, and data volume increasing exponentially, like what you see. Okay, digital universe. So it was very small before, now it's already quite big, and the size is getting bigger and bigger. Exponential increase in collected and generated data. And Twitter generates 12 terabyte every day, and Facebook generates 25 terabyte every day, and we don't even know how much that Google generates for each day. And the data generated from RFID and camera phones and GPS. And so on. So lots of data generated from many different sources. And the variety also can be considered as complexity. Shows what relational data, and text data, and semi-structured data, and graph data, streaming data, and public data, online, weather, finance. So we have a very different type of data. Here, all this type of data needed to be linked together to be analyzed, and each customers are connected, generating and connected to the banking account for their jobs and their purchase things and their personal SNS and hobbies and many others. Each person is connected to many diverse and complex and varieties of data. And also the speed and velocity. If data is being generated fast and need to be processed fast. So if we make a decision late, then we may lose the opportunities. So e-promotions and health monitoring and all those is very important for healthcare monitoring. Yeah, if somebody just had a stroke, heart stroke, then it should be answered in a very short time, require immediate reaction. So we need on those big data. Yeah, the velocity is one important factor to be considered. And the data, this diagram shows the fast data, GPS. When you're driving, yeah, we need immediate response to decide the direction to be headed. And progress and innovation is no longer hindered by the ability to collect data, but now by the ability of the manage, analyze, summarize, and visualize, and discover knowledges from the collected data in a timely manner and in a scalable fashion. And and real-time analytics and decision requirement is needed for each customers. And now we are at the beginning of all this. And in addition to the volume, velocity, and variety, but also some are counting the first factor, which is called the veracity, because many of data are in doubt, uncertainty due to the data inconsistency and incompleteness, ambiguities, etc. So this should be also considered. The data is not like what we had before. It's a different natures. And now we have to think how to make use of these data. And these are the things: online transaction processing, online analytical processing, and real-time analytic processing. And these are the things that we need to go through. And then here for the business intelligence, as occurring and reporting and data mining technique and structured data, and those are forcing those on this business intelligence to predict things. And for high predictive analytics and data mining, we need to know the optimization and predictive analysis and complex statistical analysis, and also we know we have very large data sets. So as the environment will change it, we need these in addition to the earlier techniques and the knowledges. And evolution of the business intelligence, and in 90s we had data warehouses, but in 2000s, and SQLs, and in 2010 now we are at the big data and Hadoop, Spark, etc. And all these converging to the big data, real time and single view. So this images also comes from, I think, Huawei power presentation in earlier. Okay, big data is more real time in nature than traditional data warehousing applications, because traditional data warehousing architecture are not well suited for big data applications. So shared nothing, and because those big data shared nothing, massively parallel processing and scale out architectures are well suited. So now the big data that we have are well suited for those. The nature of the big data that we have are well suited for big data applications of today. Okay, and this show what cumulative cash flow. Yeah, they are more monies are using for big data analytics these days. And also cloud computing is the one factor that also we should consider. And the classification of cloud computing are infrastructure as a service and platform as a service, software as a service. And these showed infrastructure and platform applications for cloud computing. And this comes from Wikipedia. And the benefit of cloud computing is cost and management and reduced time to development and also scaling and reliability and sustainability. So these are also the things that we should and also should know and effect the analysis of the data that we have now. Okay, now then, big data and machine learning, artificial intelligence. What is the difference between those? How they are related? The answer was given in Quora in this address, which is like this. Artificial intelligence is defined in this way, and machine learning is sometimes include the AI subject. This subject is with turning data into information and taking decisions based on that. And some algorithms are classifications and neural network and structured vector machines, etc., and clustering and regressions and feature selection, including FPCA, ICA, RFE, and forecasting and collaborative filtering and NICOM, etc. And many data-based learning and decision systems are developed using these techniques in the area of finance, healthcare, retail, e-commerce. Okay, here so, and then the data mining is what this field is mostly concerned with extracting information from a vast amount of data. Google search is one example of such a system. It is not exactly a technical subject, rather application of different algorithms. Okay, all search applications, text summation, and question answering system example of this data mining. So this is a kind of the answer for these questions that was found in there. So now let's just take a look at one example of artificial intelligence, which was quite popular in the last month, AlphaGo, which used more than 1,000 CPU and 176 GPUs. Which deals with deep learning, reinforcement learning, and Monte Carlo search trees. So this became a big issue in Korea over a month. Okay. Some commentator believe that AlphaGo's victory makes for a good opportunity for society to start discussing preparation for the possible future impact of machines with general purpose intelligence. This says the winning of AlphaGo over the Sedol, Lee. And this information just come out from after third match of those by Martin Mueller, which explains the structure of AlphaGo. And AlphaGo was he referred to the paper which was published in the journal Nature. And here, what? Search, MC, simulation, supervised learning, policy from master programs, improve the details. So, so actually, this paper was published 5 months before the match started. So he mentioned that he really don't know what has been improved since the paper published. But he tried to answer the reinforcement learning from self-play for value network is a new functions, and the reinforcement learning from self-play for policy network was also the new feature that AlphaGo showed in the big match between AlphaGo and Sedol Lee. And here the value network and the policy network was explained in this way. For value network, given a go position and compute the probability of winning, no search, no simulation, but just the static evaluation function, use it, and trained by reinforcement learning from self-play and train a deep neural network. Similarly, the policy network is trained to propose stronger moves, like this example shows. putting it all together, and a huge engineering effort was made, and many other technical contributions was added, and massive amount of self-play training for the neural network was made, and massive amount of testing and tuning was made, and large hardware was used on this game with Sedol Lee. So this, and also he explained the rules for the Go game. It's a Korean Baduk, and start with the empty board and move. So everybody knows a little bit of this traditional Korean game, Asian games. The goals are surround the empty point and capture the opponent's stones. Winning means control more than half the board. And this is so. This shows one example at the end of the game for the small size 9x9 board Go game. Anyway, this was the reaction after the game one. Shock, disbelief, huge media interest worldwide, like what you saw in here. So, is there anyone who didn't see this match? None of the 5 matches. Is there anyone who did not see any of these matches? Live or later? So everybody, like everybody over here, looked at it, some part of this, and it attracted the huge interest, and also that means Google and made lots of money out of this too. And to understand how artificial intelligence are capable of playing games such as chess and Go, we have to understand what is the game tree. And this explanation was made by Professor Kam at Arju University in Suwon. And the brute force tree search was explained in here. A game tree represents game states, positions as nodes in the tree, and possible action as edges. And the Monte Carlo tree search is an alternative approach to searching the game trees. And Deep Blue, and also he explained the Deep Blue and AlphaGo. And in 1997, the Deep Blue was the 259th fast supercomputer with 11.4 G flops. But now, in October of 2015, AlphaGo already have 1,202 CPUs and 174 GPUs. And Galaxy S6 that many of you have has already 34.8 G plots, which is over this supercomputer that we had before. So how we do think of game trees and low computing and or evaluations, like what you said, policy and things. And here, this shows the two policies to deal with the Go games. In here, the neural network and learning algorithm was used, and one example of the algorithm which was used is a kind of which can be explained in the model of the dog experiment by Pavlov. And here, when he gives food, when a person gives food to dog, and whenever he gives the food, he gives also the sound with it. Then after a certain time, if the person do just ring the ring a bell, but still the dog are expecting to have some food, so he's filling out what 침 이거 뭐라 그러나? What? Yes. So this kind of the method and knowledge could be used, must be used in these algorithms. Sure. Here in really the AlphaGo used the supervised learning and unsupervised learning and reinforcement learning. And supervised learning is what you provide him with an answer sheet when you teach. And unsupervised learning, and there's no answer sheet, and agent is all on his own. He's learning by himself. And reinforced learning here, and the technique is whenever agent provides with the right answer, a trainer tells him a good agent. If not, then tell him it's not, and so it's not good. So he just learning which one is better for him. And this graph shows supervised learning, this map, and this shows unsupervised learning, this deep neural network. And this is a case when it wins, and this is not, it's losing. And this is unsupervised learning and reinforcement learning. This shows is a revised, it's what modified neural network shows it, neural network. Here, the value of state is decided by value network output and simulation. So to give the winning. And this shows it, and this diagram was made by Miss Professor Kam at Arju University. Here, artificial neural network are a class of model that is frequently used in machine learning, both in the supervised and unsupervised setting, because of the ability to handle large amount of training data. So these are the so mathematical background can be which must be used in AlphaGo. And AlphaGo use Monte Carlo matrix search system and breadth reductions, and policy network was used, and depth reduction also added, which is can be considered the policy networks. So value network and policy network were both used together to make a right decision for the next move. So AlphaGo relies on convolutional network for the policy and value network, three convolutional network, which consists of two policy network and one value network. This is the fact how this introduced in his paper, Nature. So the very interesting match was the game 4 of between AlphaGo and Sedol Lee. And Lee is a new strategy: take lots of profit, then stake the game on invading the center. The Lee came very close to losing all the center. Then he produced a fantastic Tetsuji, and AlphaGo needed to compromise here, but it still, though it could get everything and made things much worse for itself. And I think this was the key that made the big changes and made the history. So the Sedol Lee won the first, had the first win over the AlphaGo here at the game 4, and the discussion was made by many. And why did AlphaGo miss this game? And complex tactical fight, multiple target and many threats. No subset of threat works, but all together they worked. Computer lost in combinatorial explosion, and that was the kind of discussion which was made. And human can precisely plan. And humans only hope one out of calculate the computer. Well, many of discussions made after this, and he was very much relieved after the first game. But eventually, the AlphaGo won the last game too, so it was the history was made in there, and all those was recorded in wiki here. That the game 4, David Omerod of Go Game Guru stated that he believed it was a result of known weakness in play algorithm which use Monte Carlo tree search. In essence, the search attempted to prune sequences which are less relevant. So in some case, we could put the machine in danger. We could play with him. If we think more. And this is a whole. This shows the real game of fourth game. And this is a kind of the information which was summarized in Wikipedia. AlphaGo versus Lee Sedol. The Google DeepMind Challenge match was a 5-game Go match between South Korean professional Go player Lee Sedol, and AlphaGo, a computer Go pro game developed by Google DeepMind and played in Seoul between 9 and 15th March 2014. AlphaGo won 4 games out of 5. The match has been compared with the historic chess match between Deep Blue and Garry Kasparov in 1997. After this match, Korean Badog Association awarded AlphaGo the highest Go Grandmaster rank honorary Gudan. It was given in recognition of AlphaGo sincere effort to master Go. Actually, I'm a graduate of Chungham High School, which is the best high school for who produced more than half of the professional Go player in whole Korea. And the rank of addition of the rank of the graduate of Chungham University in Go plays is almost 60%, 70% of the whole number of the Dan in Korea. But so yeah, Lee Changho was my junior student, and many others. So I had the interest, and it was very interesting to see this, and also it was good to know that our mathematical knowledge can be used to understand and analyze and make a tactic to play better. And also the Gyeonggi Gangwon Math Society will have a meeting in June 3rd and 4th at Gangneung National University, and one plenary speaker who is a professor of National University, Hyung-in Choi, will talk about the mathematics behind the AlphaGo at there. I will supply more information on that. So. Okay, I think that's the end of the one example of the artificial intelligence and machine learning and etc. And yeah, you may just so if you summarize, with this we already started to talk about the subject, including statistical learning and supervised learning, unsupervised learning, and data mining. Okay, so yeah, each team will make their presentation material uploaded in iCampus before next Monday, and we will talk a lot on those to add the comment to make it better, and on Tuesday, and then I will give you an order for your presentation on Thursday, and maybe another day as well. So yeah, it's time to go through it. So, and also team project was assigned, and after your presentation, you can concentrate on your final examinations. And these are the things. And one thing that thing is, each group will have a short presentation, and each group will provide a 5-page document. More than of this is okay. Sure. Yeah. And the responsibility and work of each student shall be described precisely in your project, as well as your the document for the presentation. I think that's it for today. Any questions or comments?